Hello everyone, my name is Sachin Kumar and today's topic is differential equation. So let's start. In this topic, we will go to introduce our topic, differential equations, and then we are going to form a differential equation, order and degree, and method of solution, and looking into some problems in the end. So what are differential equation? Before going to the definition, we look into something. If I have a function like this, it has two components. One is dependent variable and is independent variable. Here we call f as a dependent variable and x is an independent variable. Like if we have y equals to mx, here y is a dependent variable and x is independent variable. Similarly, if we have a f equals to x square plus y square plus z square, we have two things. F is a dependent variable and x, y, z has an independent variable. So dependent variable can have one or more than one independent variables. In a definition, we will look into it is an equation involving derivative of a dependent variable with respect to the independent variable. In a differential equation, there must be at least one term which is the derivative of dependent variable with respect to independent variable. Like in this, here y is a dependent variable and x is an independent variable, and here is a term which is a derivative term of a dependent variable over independent variable. Similarly in this equation, here x is a dependent variable and t is an independent variable. And if we look into this, f is a dependent variable and x comma y are the independent variable. So this is all are the differential equations. Now if we move to the type of differential equation, we have two type of differential equation. One is ordinary differential equation and second is partial differential equations. In ordinary differential equation, dependent variable have only one independent variable. However, in the other hand, partial differential equation have dependent variable which have more than one independent variables. In ordinary differential equation, we use a total derivative like dy over dx, d over dy, like this. And in a partial differential equation, we use partial derivative like del over del x, del over del y, like this. For example, this is a differential equation. Now here y is a dependent variable and x is an single independent variable, and we are using total derivative here, d square over dx square. So this is an ordinary differential equation. Here u is a dependent variable and x and y are the independent variable. Here we use partial derivative del square over del x square and del square over del y square. So this is an partial differential equation. So we are able to classify between ordinary and partial differential equation. In our course, partial differential equation are not there to solve, only ordinary differential equation are there. So we will look into this only. Now formation of ordinary differential equation. Let's say we have a problem called form a differential equation of the given equation this, where the a and b are the arbitrary constants. So let we have y square equals to 4a x plus b. Here a comma b are the arbitrary constants given in the equation. So first is objective is to find arbitrary constants. So we know a and b. Sometimes problem already give that these are the arbitrary constants. Sometimes we have to find it. Otherwise, in second step, we have to remove arbitrary constant using differentiation. Now using differentiation, you have to remove these arbitrary constant. Let's say we have to differentiate this equation with respect to x. Now after differentiation, dy over dx 2y dy 4 of a. Now a is still there, which is an arbitrary constant. We have to remove it. Now we are differentiate this equation again. We will get 2y d square y over dx square plus y 2 times of dy over dx whole square equals to 0. Now we will remove 2 to 2, we get y into dy over dx square plus dy over dx whole square equals to, this is a required differential equation of a given equation. Now as we see that I differentiate the equation as many as time as the total number of arbitrary constant. Here are two arbitrary constants. I differentiate the equation two times, one time here and one time here. So you have to differentiate the given equation as many as times the total number of arbitrary constant present in the given equation to remove them. Just like take an example here. Here m is an arbitrary constant. There is only one arbitrary constant. Here are two arbitrary constant a and b. So I cannot differentiate more than one time this equation. So I differentiate this equation dy over dx with respect to x, which is m. Now I cannot differentiate more than one time, so I have to but I have to remove it. So I replace this value from the original equation. So we will get a y equals to dy over dx into x. So the required differential equation became like this. This is the required differential equation of the given equation. Now if we are looking at here, now differentiate this y dash. Y dash is nothing, just dy over dx. It is a matter of representation, equals to minus of a sin x plus b cos x. Now again differentiate this equation. Now minus of a cos x plus b sin x. Now this is nothing but y. So y double dash equals to minus of y. So y double dash plus y equals to 0. This is the required differential equation of the given equation in which arbitrary constants are not present. So if we move on, now we have a question together y equals to, this is the equation whose differential equation is this. Then we have to find what is phi x over y. So let we have y equals to x over log cx. Now we differentiate this equation, like take log here cx x by y. I can write it as log x plus log c equals to x by y. Now differentiate the equation with respect to x. So we will get 1 by x plus 0, which is constant, and differentiation of is y square y 1 minus x y dash. Now I can write it as y square by x equals to y minus x into y dash. Can write as x into y dash equals to y minus y square by x, and I send as y dash equals to y by x minus k y square over x square. Now compare this equation, or the given differential equation is this. So we get phi x over y nothing as minus of y square over x square. So our correct answer will be D. Same, if we move on, then what is order and degree of a differential equation? Order is nothing but highest derivative term present in the equation is called the order of the equation. Like if we take d square y over dx square, which is the highest derivative present in this differential equation, so it is of order 2, so the order of the equation became 2. Similarly, in this equation, highest derivative term is this and not this, so this became the order of the differential equation, which is 2. Now degree is nothing but the power of the highest order, power of highest derivative term present in the equation. Okay, so this is a differential equation in which the highest derivative term is this, whose power is 2, and this is in the lower derivative term whose 3. So highest derivative term is this, so his power is 2, then this became a degree of this equation is 2. So in our course we have only those differential equation which have first order and first degree. Only these differential equation we have to solve. Other differential equation are not in our course to solve. So method of solution of ordinary differential equation. Now we classify into two things, like ordinary differential equation are homogeneous, non-homogeneous. Then further it is linear or non-linear. We have several different methods to solve it. Like if we have a homogeneous linear differential equation, we can use the separation of variable method, the reduction to separation of variable, method of integrating factor, Bernoulli's equation. Here non-linear terms are not in our course, so we are not involving any term method to solve this equation. And which is one method also non-homogeneous equation, which is linear, so we can use the reduction technique to reduce the non-homogeneous to homogeneous differential equation. So but in today's video I am only covering this method of integrating factor to solve ordinary differential equation of first order of first degree. So method of integrating factor here is this integrating factor solving the first order first degree linear differential equation. Now first we have to know what is integrating factor here, and then we go to this general form. This is a general form of first order first degree ordinary differential equation, which is linear. Now what is integrating factor is? Integrating factor is nothing, just a function which make differential equation exact or as a perfect. What is the meaning of perfect or exact? Is that, take an example, if we have a differential equation like this, if we multiply x in this equation, it will become like this. Y dash equals to 0. Now this is nothing, we can write it as x into y equals to 0. Now this equation became a exact differential equation or a perfect differential equation when we multiply by this function x. So such type of function which make a differential equation exact or perfect, we call them at integrating factors. Oh sorry. So now if we go for the general method, y dash plus py equals to q. Here p and q either constant or function of x. So if we multiply this equation by e की power integration p dx, both side we will get y dash plus p y equals to q into e की power integration p dx. So this equation became like this, integration q integration p dx plus y into p times of e की power integration p dx q into e की power integration p dx. So this is nothing but a perfect differential of d over dx into y into e की power integration p dx equals to q into e over y. If we integrating both side we will get y into e की power integration p dx equals to integration of q e की power p dx into dx plus c, which is an integrating constant. So this is a required important formula for this equation. So what if we get an any equation, steps, what steps we will follow? First step, reduce the given equation in y dash plus p y equals to q in this form. Then find what is p and q, and then step 3, find integrating factor which is e की power integration p dx, and fourth put it in the formula. Put it in the formula, which is y into integrating factor equals to integration q into integrating factor dx plus c. Now the required solution will be here. Like if we take an example here, y equals to y dash plus 2 times of y equals to 3 times of y equals to 2, like this. Now where the p is 3 and q is 2, and now integrating factor will be e power integration 3 dx equals to the e power 3x is the integrating factor. Now put it is in the formula. First step is this, second step is this, third step is finding, and then fourth step is put it in the formula is this. Then y into integrating factor e power 3x equals to integration of q 2 into e power 3x dx plus c, which is an integrating constant. Now if we get the solution is this e power 3x equals to 2 by 3 e power 3x plus c. This is the required solution for the given differential equation. This is the family of surface.